This is problem number 78 in section 5.3. The voters in a large city are 40% white, 40% black, and 20% Hispanic. A mayoral candidate anticipates attracting 30% of the white vote, 90% of the black vote, and 50% of the Hispanic vote. Suppose we select a voter at random. Part A asks you to make a tree diagram representing the situation. Notice that the first three statistics describe 100% of the voters. 40% plus 40% plus 20%, 100%. The second group of statistics are all conditional statistics. 30% plus 90% plus 50% add up to 100%. So clearly, those are not our basic probabilities. Those are our conditional probabilities. So we start out with dividing the voters into three categories that add up to 100%. Then we'll do the second layer. Now in the second set of branches, we deal with the conditional vote. 30% of the white voters he anticipates that 30% of the white voters will vote for him, 90% of the black vote will go to him, and 50% of the Hispanic vote. So among the white voters, he expects 30% to vote for him, 70% not to vote for him, 90% of the black voters, 10% not voting for him, and 50-50 with the Hispanic. Notice that in each set of branches, the probability adds up to 100% because we're talking about here 100% of the Hispanics, 100% of the blacks, 100% of the whites. So this is 100% of all voters. Now the third layer then is what we do at the end. At the end, we are saying what is the probability of that a voter is white and votes for the candidate, or a voter is white and doesn't vote for the candidate, or a voter is black and votes for the candidate, and a voter is black and doesn't vote. And so we're going to be multiplying all these probabilities. Now in this last row, we get the entire sample space. This would be the probability of a randomly selected voter being white and voting for the candidate, 0.12. Being white and not voting for the candidate, 0.28. Black and voting for the candidate, black and not voting. Hispanic and voting for the candidate, Hispanic and not voting for the candidate. So there are 6 different outcomes, and here are their probabilities. So each time you're multiplying together the given probability times the conditional probability, and these add up to 100%. So let's look at some of the questions then that are asked about this particular situation. As we work on these two problems, I suggest once again pausing the video, seeing if you can do it yourself, and then coming back. Find the probability that this voter votes for the mayoral candidate. Show your work. So you try it and then come back. There are 3 categories of voters who voted for this candidate: white, black, and Hispanic. So white and voted, black and voted for the candidate, Hispanic and voted for the candidate. So we add up those 3 possibilities. Probability of white and votes for the candidate, or black and votes, or Hispanic and votes for the candidate, 0.12 plus 0.36 plus 0.10, or a total of 0.78. There's a 78% that a randomly selected voter from this group will have voted for this candidate. The last question says, given that the chosen voter plans to vote for the candidate, find the probability that the voter is black. So this is known as reverse conditioning. We're going the other direction. We were told that given that a voter is black, there's a 90% chance that he votes for the candidate. Now we're asking the other direction. Given that the voter plans to vote for the candidate, what is the probability that the voter is black? This is known as reverse conditioning. Once again, see if you can figure it out, pause it, come back. We use the conditional probability formula. The probability of black, given that the person is a voter, is the probability of black and being a voter divided by all of the probability that he is a voter. So that would be black and voter, 0.36, and then the 78% over the 78% that were voters. So 0.36 divided by 0.78 is 0.615. Given that the person is planning to vote for this candidate, there is a 46% chance that the person is black.